recording. There we go. Let's just make sure I am recording. Yes, we are. All right, so we showed a little bit of Khan Academy. If you notice, I got 3 things here. Okay, what is the thing that we watch Khan Academy talk about? Which one did he talk about? The distance, okay? The distance between what? 2 points, right. He put 2 points, figured out to find the distance between 2 points, okay? Before we get to that, again, this is stuff that you probably covered in Algebra 1, and some of you forgot, but then as he went on, you're like, oh yeah, I remember doing that stuff last year. Because this is a basic Algebra 1 kind of thing. We're going to talk about a couple words. Here's the first one, and we call it an ordered pair. You've probably heard of that. Yeah. Yeah, this is a very basic, common Algebra 1 principle that we talk about, and we're going to do quite a bit here in geometry as well, okay? It's not just an algebra thing. All right, we talk about an ordered pair, and we write an ordered pair like this. We put the x first, and then we put a y. So what it does, it indicates where a point is located, all right? That's what it's telling you. It's an ordered pair because it has to be in that order. The x has to go first, the y has to go second. That's why it's ordered. It's a pair. Take a wild guess why it's a pair. Because there's 2 things in there. That's right. You got an x and a y. There's 2 things. That's why we call it an ordered pair, all right? And we write that ordered pair on a thing, and you may, I don't know if your teacher taught you this or not, but on a thing that we call a Cartesian plane. You ever hear that? The word Cartesian seems kind of weird, but sometimes when we have weird words like that, it's usually named after a certain person, and it is. It's named after a guy with kind of a girl's name, Renee, but there's a lot of French guys that are named Renee. This guy was French, all right? So in France, or maybe even in Canada, Renee's a guy's name, all right? But here in America, we think of Renee as being a girl's name, but it is a guy, and his name is Renee Descartes. Let me make sure I spell this right. I think in the past, I've spelled this incorrectly, all right? But it looks like Descartes, but it's Descartes is how, I guess, I don't know. I don't speak French. You know, we actually have a couple people here that speak French. Did you know that? A senior, Seydou. Do you know Seydou? He's new this year. Big, tall kid. I think he plays on the soccer team. But anyway, he's from Mali, which is I don't know if he was born there, but I'm pretty sure his parents were born there. I think he might have been born there and moved here. I think he was. Then he moved to like New York. He lived in New York for a while. His family did, and then they moved down in this area. But in Mali, which I had never even heard of, that's a shame because I like to think that I know a little bit about geography. But I said, what language do they speak there? And he says they speak French. So anyway, we got a couple people. We had a girl last year that spoke French. She was from Canada. So I just thought that was interesting. Okay. They're supposed to be bilingual. So in certain parts, like in Quebec, which is where Montreal is, it's like a state, but they call it a province. They actually were going to break away from Canada because they're mainly just about all French speaking in Quebec. And several years back, there was this big thing that they wanted to break away from Canada to be their own country because they're just so different than the rest of Canada. But they speak French. We took a senior trip when my son was a senior. That was it was 2009. We went to, it was near Montreal. We went up above Montreal. We did the ski trip to this place called Mont Tremblant. And it was really fun. We went skiing and all that kind of stuff. And it was in Quebec. This kid in our in the hotel, they were messing around like guys do, and he hit his head, and we thought he had a concussion. So we called the ambulance. So the school nurse was with us, and I went along with her, so she wouldn't have to be by herself in this different country. So we went to the hospital, and it was hard finding people that spoke English. And I always thought, when you go to Canada, I thought everybody spoke English, I thought everybody spoke English, and then a lot of people spoke French on top of it. But there was a lot of people there that didn't know English at all. And it was kind of crazy because I've been to Toronto. You go to Toronto, it's just like going to America, right? It's anywhere in America. I mean, everybody speaks English, the accents, except for saying, a boot, and instead of about, they say a boot, that kind of thing. And they say sorry. They say sorry instead of sorry. Yeah, they do spell a few things a little different than we do. But Toronto, was very, very similar to the United States. You wouldn't even know that you're in a different country, except when you went to get gas, it wasn't in gallons, it was in liters. When you looked at the mile markers, it wasn't mile markers, it was in kilometers. So there was a few things different. But in Quebec, it was really different. I mean, you really felt like you were in a different country, even though you are, because it was Canada. Well, anyway, enough of my French stuff. I don't know much about France or any of that, but that's this person right here. This was a long time ago. This guy came up with this stuff. 1596, this guy was born to 1650. So he wasn't much, or I'm just a little bit older than he was when he died, right? But he made such a mark on the world that we actually named some of the math stuff for his name, okay, Renee Descartes. He was a French philosopher. He was a scientist. He was a mathematician. So we're going to talk about the math stuff. All right, enough of him and enough about Canada. I really did not plan on doing that. All right. I just happen to have a Cartesian plane right here. How about that?
Oh, yeah. I see these all since like...
Exactly. So you may not have known what the name of it was, but now you see it and you're like, oh yeah, I've seen that plenty of times, right? You did a lot of this stuff in Algebra 1, didn't you? Okay. So, yeah, sometimes they call it a coordinate plane. Okay? Because when you put a point, the location of a point is called a coordinate, all right? So they call it a coordinate plane. So let's talk about this just a little bit. I'm going to change colors here. Let's go this light blue. All right? We have these two thick lines right here. One's horizontal, one's vertical. Okay? We call this an axis. And this one, the horizontal one, we call the x-axis. All right? The one that goes left and right horizontally, that's the x-axis. The one that goes up and down, or what? If this is horizontal, then this one is what? Vertical. Okay? We call that the y-axis. All right? And remember we talked about that ordered pair? Which one goes first? The x goes first. That's easy to remember because it's in alphabetical order. Okay? So the x is first and the y is next. Okay? We have another thing that we want to talk about. Right where those two axes, so axis is singular, axes is plural. Okay, that's the plural for axis. So if I talk about both of these, it would be the two axes. Okay, where they intersect right there, you said it, it's the origin. Okay, will you see it? Yeah, I guess. Yeah. So the origin is right there where they intersect. Now, we have an ordered pair for the origin. This is where we begin. Okay, so where you begin, the ordered pair for it is 0, 0, because it's 0 on the x and it's 0 on the y. Okay, that's the origin. Now, if I was to put a point on here, let's do this in a different color. I'm just going to do some random point. Let's do a point right there. Okay, if I wanted to figure out what the ordered pair of that point is, where do I always start? I always start at the origin. Okay, that's the beginning. Origin means beginning. Okay, and so, right, you do the order that it tells you, right? You go in the x direction first, and then you go in the y direction. So that means we go left and right first, and then we go up and down next, all right? So if I'm going to get to this point, am I going to go left to get to that point? No, where am I going to go? I'm going to go right. So I'm going to go right. I'm going to just put a little x, not going to put a dot there. I go that far. So let's count over how many we went. 1, 2, 3, 4, 5, 6. So we went over 6 in the x direction, and that would be positive. We go to the right, that's positive. If we go to the left, talk to me, that's negative. If we go up, we go positive. We go down, we go negative. Everybody got that? This is all review, isn't it? Yeah, that's why I'm going a little bit quick. All right, so if you go over 6, yes, you. Why? Why would you even ask? If you go over 6 and you want to get up to this point, then we have to go up. How many do we go up? 1, 2, 3, 4. So that ordered pair is 6, 4. What if I asked you to plot the point? A lot of times, if I asked you to put a point at a certain spot on here, I would say plot the point, okay? Or plot -3, -5. Just making stuff up, okay? And you make sure you put a comma. It's supposed to be a comma in between those, okay? So again, where do we start? At the origin, and we go -3 this time. So we go to the left 3 places. 1, 2, 3, right here. Don't put a dot yet. Just keep your pencil there. And then we go -5, so we go down 5. 1, 2, 3, 4, 5, right there. So that point is -3, -5. Okay, so I could put points on a plane, on a Cartesian plane, and ask you what the ordered pair is, okay, or what the coordinate of that point is. Or I could say, plot a certain point. So you put a dot, and what I would do, I would put -3, -5 right here. Question? I think we're okay just drawing a graph, okay? I just did this to make it a little easier and, a little nicer looking, but you don't have to have graph paper for this. We're not going to do that much where you're going to have to use graph paper, so I would be fine with this. Like if on a test or a quiz, I'll probably put one of these blank Cartesian planes on there so that you can make it nice and neat and it's not all sloppy and stuff, okay? Because I know how it gets when you just try to draw a line, without having a ruler or something, sometimes it can look a little gross. But I'll give you that if we have a test or a quiz on it, okay? Let's see. Is there anything else I need to talk about? Oh, let's talk about this. Almost forgot. Let's do this in a different color. So it's a little bit different. We have these 4 blocks. Do you see how this makes this upper right block? This one makes this top left, and then bottom left and bottom right. We give those things names, those areas names. What do we call those? There's 4 of them. We call it a quadrant. And we number them 1 through 4. Which one is the first one? The top right one. Yeah, where they're both positive. And we usually use Roman numerals, okay, to name the quadrants. So I'll write the word down. It's a quad. Why do they use the word quad? Because it means 4, right? And we've talked about that before, quadrilateral, right? So that's a prefix for 4, so that's the first one. Which direction do we go? We go left, okay? So we go what? Clockwise or counterclockwise? It's counterclockwise, right? So we go 1, 2, 3, and 4. And again, we use Roman numerals usually to do that. We know our Roman numerals up to 4 at least, right? Okay, should be good with that. All right, so that's pretty important to know what quadrant it's in, all right? By the way, in the first quadrant, let's just put an ordered pair, but let's just put the signs, okay? What's the sign for any point in the first quadrant? It's going to be positive, positive. What about the second quadrant? Is it? Negative, positive, right. Negative, positive. And then the third quadrant? Negative, negative. And the fourth quadrant? It's positive, negative. Okay, so anything in here is always going to be positive, negative. Anything in here, negative, negative. What if we actually are on the axis itself, like right here?
0, then 1.
That's right, because you start at the origin, and you always go x first, and then you go y second. So how far on the x direction do we have to go to get to that yellow point right there? We don't go anywhere. We go 0, don't we? All right, so anything on the y-axis is going to be 0, comma, however far we went. How far did we go? 1, 2, 3, 4, 5, 6. Good. All right. And of course, let's put one right there. If we put one right there, what ordered pair would this be? I'm sorry. That's not what I wanted. Sorry. Let me erase it. Let's go over here. Let's put one right there. That's what I wanted. So what would that ordered pair be? 1, 2, 3, 4, 5. Yeah, I got something about 6, don't I? I don't know why, but anyway. So I've got -6. And then how far up and down did we go?
0.
We go 0. Okay? I think we pretty much covered it as far as this.
Would you ask us, you wouldn't ask us to name what point the quadrants in if it's on a line, right?
I mean, I could. I doubt I would do that because this is real simple stuff. To tell you the truth, I really doubt that I'm going to give you a quiz where I'm going to ask you this little simple stuff right here. Okay? This was just a foundation, right? Just to make sure we're on the same page, all right? You did this in Algebra 1, but, people come from different schools. You get, you're taught different things. Who knows what you've been taught. I just want to make sure that we're all on the same page on this stuff, okay? All right. Now, let's get to what Con was talking about yesterday. And I think we're just going to do the distance stuff, all right? So let's do this. Let's put a point. And just like he did, I'm just going to do some random point, all right? There's a point right there. I'll tell you what, let's change the color of that. What color do you like? The blue? Can you the pink? All right, we'll do the pink. All right, let's put a point right here. And let's put a point right 1, 2, 1, 2, 3. Yeah. Let's go right there, okay? I just picked 2 random points. Everybody got it? What I want to do is I want to find the distance between those 2 points. Now, we've already done distance before. Remember we had that number line like this, and I had a 3 here and a -2 here, and I said, what's the distance between those? How did we do that? You could just count. But on this one, can I just count? Let's make a straight line. Let's connect them. Well, no, not for distance. So if I wanted to find the length of that pink line right there, okay, just up here, okay, forget the x1, x2, and all that kind of stuff. Just right here, what would I do to find how far it is from -2 to 3? You could just count, but watch. You could count here because you're just going straight across, right? But right here, can I really count? I don't really know, like, see, I'm not hitting those little grid marks, so I can't just sit here and just count diagonally like this. So that's not going to help me out. All right, or at least I won't be accurate. All right, you might be close, but you won't be very accurate. So I just can't count because it's diagonal like this. But horizontally, I could do what? Instead of just counting, what math did I do? Did I add those 2 numbers together? What did I do? I subtracted. You guys are looking like I haven't taught this before. We did this before. You don't remember? Yes? No? We didn't? So you could do this. You could just go -2 minus 3, or you could go what? 3 minus, not 2, minus -2. All right, because this is not at 2, this is at -2. But you remember this part, right? Remember I put absolute value? Why did I put absolute value? Because you can't have a negative distance. Right, you can't have a negative distance, okay? So that's what the absolute value does. So what's -2 minus 3? It's -5. The reason we put it in absolute value is because we don't say this is -5 distance. We just say it's what? It's 5, okay? Same thing works with this, okay? And that's 5 as well. All right, you remember that stuff, right? I don't know. You're scaring me because I thought that was pretty basic and you didn't know to subtract, or maybe you just didn't say anything. But what we're going to do here is this. We want to find the distance from here to here, but we just can't count 1, 2, 3, 4 because those marks don't line up. So what we have to do is count over and then count up. Okay, it's kind of rise over run, but that's different. Okay, we will do that in this lesson. All right, this lesson's pretty long, so I broke it up into 2 days. All right, so we will get to that probably tomorrow. But what we're going to do is this. We're going to count from here all the way until you get underneath of that point right there. We're not just going to count. We're going to do some subtraction. Okay, and then let's do this in a different color. Then we're going to count, or we're going to subtract, find the distance, I should say, from here to here. Okay, we're going to find the yellow one, and then we're going to find the green one. But let's do this. Let's put the points, let's put the ordered pairs for these 2 endpoints right here. So this one down here at the bottom, what's that going to be? You start here and you go what? 1, 2, 3, 4, 5, 6. 1, 2, 3. So this is negative, oops, I thought I went to pink, but -6, -3. You with me on that? Okay, what about this point up here? Where is that? 1, 2, 1, 2, 3, 4. So this is at, oops, 2, 4. It's pretty easy, right? That's what we just got done talking about. All right, so I want to find the distance between this and this. I just can't subtract like I did when I did this stuff over here. What I have to do is I got to find this length and I got to find this length. Well, let's do this. Let's find that point right there. It's not really part of our line, but this is going to be helpful to us to find this point right here. So what would this point be? So how far over did we go to get to this point? We went over 2. This is right under it, so this has to also be what? 2. Okay, and then we went over how far to get to this point, to the left. How far to the left did we go? We went -6. I'm sorry, I lied. I don't want to go over. I want to go down. I'm sorry. So how far down did we go to get to this point? We went -3. So what's this? That's -3. So that point is 2, -3. This is what we saw in the video yesterday, but I'm just going through it one more time for you. Okay? It was corrections, and then yeah, you didn't really miss anything because I'm just reteaching what I showed you yesterday. Okay, so now what we're going to do is this. Remember, I can find the distance horizontally, and I can also find the distance vertically. It's the same exact thing as doing horizontal, except you're just going up and down. So what would the distance be from this yellow line? What would that yellow line distance be? Well, again, where are we on the x-axis? We're at -6, aren't we? Where are we on the x-axis here? At +2. So how do I do that? It's -6, what? -2, which is, it's -8, but we always take the absolute value, which is what? 8, okay? So how far is this? The yellow line. It's 8. You with me? Okay, now what we're going to do is we're going to find the green line. So let's look at the y's because we're going up and down. So where are we up on that green line? We're at 4. Where are we down on that? Where are we at this point right here? We're at -3. So we're going to go from 4 to -3. So we go 4 what? Minus -3, which is 7. You could put it in an absolute value, but it's already positive. All right. So the green is 7. You with me on that? Okay. So here is what the new stuff is. The new stuff is finding the length of this pink. So we kind of do it indirectly. We find this length, we find the horizontal length, we find the vertical length, and now we've got a triangle out of this, don't we? Okay, what kind of a triangle? It's a right triangle because you got horizontal and you got vertical. That makes a right angle. So it's a right triangle. Now here's something that we haven't talked about yet this year, but it's something that you should have done in Algebra 1. Okay, do you remember doing this in Algebra 1? It's called the Pythagorean Theorem. Now, Pythagorean, that's a weird word too. It is actually named after some guy a long time ago. I don't know what his date was. I don't know. I'm not even going to guess. I was going to say before Jesus' time. It could be. He might have been BC. I'm not really sure. You got Google. You can look him up, okay? But it's named after a guy named Pythagoras. Have you ever heard of that guy? He was also like a philosopher, but he was also a mathematician, okay? He walked around. You know how Jesus had 12 disciples? He wasn't the only guy back then that walked around with teaching a bunch of people. There was a lot of people like that. That's how they had school. They didn't have school like this, where they all met at 8 o'clock and they had classes. They got their education by walking around learning from these educated people, right? That's why Jesus had his disciples. It was not uncommon to have people following a guy around, all right? So Pythagoras had some people following him around, all right? Now, he wasn't God, all right, like Jesus was, but he did have a lot of good insights, I guess, that you could learn from. But it was named after this guy right here. He actually proved the theorem. He didn't actually come up with the theorem. They actually knew the theorem way before him. So even like around Jesus' time, they knew about right triangles. Isn't that crazy? I mean, think about the pyramids in Egypt. They had to know a lot of math. They had to know a lot of trigonometry. They had to know a lot of stuff, okay, to be able to build those things. They didn't just start piling rocks up. I mean, it's a very mathematical, it's an engineering marvel. And they had to know a lot of math. And they knew that even back then, way back in Moses' day, all right? They knew a lot of this stuff, all right? So let's take a look at this. What is the Pythagorean Theorem?
Dinner for interruption. We are starting with 9th grade for your pictures. Please bring your picture order form, and you're going to go to the TC lobby. All
Figures.
grade please go for your
All right, let's just do this super quick, okay? You can just give them a few minutes, okay? So watch. A squared plus B squared equals C squared. The C always has to be the hypotenuse. Do you know what the hypotenuse is? It's the opposite side of the right angle, okay? So it's the pink one, right? So what we're doing is we're solving for C, all right? So what is, we'll call this one A, and we'll call this one the B, and this one is the C, all right? So what are we going to do? We're going to go 8 what? Squared plus 7 squared equals what? C squared. So here's how we do this. What's 8 squared? 64. Somebody do this math for me. The 64 plus 49 equals C squared. That's 9, that's 3, that's 10, that's 113. Is that right? Equals C squared. So now you thought Khan was cool with his calculator. Check this out. I got one too. So not to be undone by Mr. Khan. So what do? We put, where is the square root? Right there. See, there's the square root of 113. Do you remember how to do that? And you get about 10.6. So C is approximately, why did I put approximately? Because look, it keeps on going. It's called an irrational number. Keeps on going, but it's approximately 10.6. Okay, so I did give you some homework. Now, you may not be able to do a chunk of this homework, but all the stuff with distance, you should be able to do. But I'm just going to give you the assignment anyway, and we'll finish it up tomorrow. So work, here's your homework. It's, where are we? Pages, yeah, I know, but I'm going to write it anyway, because if people need to go to YouTube and watch it, which nobody ever does, because every time somebody comes in here and says, what was for homework? And what do I always tell you? Right, go to YouTube and watch it. So this is section 3, 4. There you go. That's your homework.